They're all in there. Maybe I try to scrape a bit more. But they are inside, they are crawling along the tunnels. Like this.
So that's the tunnels.
These things are like, they call it frass. F-R-A-S-S.
Fresh.
So it's like when they chew through the bark, then they leave all the residue. It gets pushed through the fissures.
Right.
So their nest is inside the bark. I don't think have to go under the microscope. Yeah, I got some.
Okay. There it is. You're right. He walks in such a
They cannot work properly.
strange manner.
They cannot work properly.
I would have never guessed that this is an ant from
Because it's so small.
and it's so
No,
round.
it's not. She's not attached very well. I don't deal with live ants.
Oh yeah.
You did. Yeah, as in, I think the main takeaway is that like there can be species that look very similar but are actually different, and you can differentiate these species using a combination of methods involving DNA and morphology. But each method taken on its own has its caveats. So let's say, for example, like geometric morphometrics. As in, you might find from the analysis that you get different groups. But each group might not be different species. As in, within a species, there can be variation also. So, the sensible thing to do would be to have a DNA result, then using that result as a base result, then you
From there
check
you
that
go.
result using a different form of evidence, like in morphology. Morphology meaning like outward appearances.
Yeah.
Yeah. So even DNA, there's like different levels. Simply speaking, there are two kinds of DNA. So in your body, there's like this thing called the mitochondria, which is like the powerhouse of the cell. So every living thing has mitochondria in order to like produce energy molecules.
Yeah.
Like to respire. Yeah, so mitochondria itself has DNA. But there's also another form of DNA called the nuclear DNA. But it's separate from the mitochondria.
Right.
So they evolve at different rates.
Oh, right.
Yeah, so mutation, evolution, like squares and rectangles, they're all quadrangles. Like mutation is a part of evolution. Because of mutation, then you get evolution. So evolution is like the result. As in, you see the results of like the mutation. As in, mutation, there can be random mutation. Just occurs for no reason. Sorry, it's been a while since I used this.
This is to observe morphometrics?
As in, this is to take the landmarks.
Okay.
Like, because I take different points on the
Of
image.
an ant.
Of an image.
Of an
Like
image.
a particular image.
Okay.
I save all my images into like one folder. Sorry, I need to look for that folder. Too many things. As in, we have a few stacking systems. Like it takes stacked images. So each end I take 2 replicates.
Yeah.
So each perspective. So there are 3 perspectives. So I take head, then profile.
It's so much data.
Head, dorsal. We call this, the technical term is like mesosoma. But basically it's a modified thorax. Like insects have thorax, abdomen. Yeah, but for ants it's a bit special. Because part of the thorax and the abdomen have merged together to form like a different part.
Part of the thorax and the abdomen have merged.
That's why for ants we don't use the term thorax. What was once the thorax has now been split into, we call it the mesosoma, then we just call this the waist segments.
Right.
So waist segments can be 1 or 2, like can be a petiole and what was the other one? Post-PTO. PTO and post-PTO. So the good thing about geometric morphometrics, as in it's different from normal morphometrics. As in you don't look at linear measurements.
Oh, okay.
It's like you compare shapes or like positions of certain points rather than linear measurements. In a sense, you can compare shapes while removing effects of size. Like the points, the red and blue are the points with the greatest variation. So in ants, there can be size variation within a species. Yeah.
Let's
But
see the-
essentially, the shape is all the same.
Yeah.
But their size can vary. But they are the same species. So that's why I chose to use geometric morphometrics. As in I use for imaging.
Wow. They're so tiny. It's so... Oh man.
Yeah, that's why we need the stacking system.
It's like a whole army of ants.
These are several colonies.
Did you focus your study on ants for a reason?
Let's start with grandmother's story again. No, as in to be honest, like I didn't start off with interest in insects. So as in ants, because for my PhD I had to choose a group of organisms that is like practical for me to complete within 3 years. Yeah, so I had to choose between beetles and ants. Then my supervisor said beetles is impossible because there are like too many families. Ants is just one family, but it's very diverse. But although it's diverse, but there's enough information out there that is as accessible for like beginners. Because at that time I was just a beginner.
Yeah.
Yeah, so he said, yeah, okay, you should choose ants. So, yeah, I choose